Hello again, everyone, and welcome to a new session of your channel, Math Made Easy. Today, I wanted to go over a new topic, uh, which is the chain rule in differentiation. Okay, I think we will start with an example and then we explain how it works. It's really pretty straightforward. So let's say I have a function f of x equals, let's start with trig function, secant, for example. And then inside, I have, let's start with an easy one first, minus 3x. And I want to find the derivative of that function with respect to x. So you ask yourself, how many really functions are embedded here? I have a secant function. That's the first thing you encounter, right? And then when you take the derivative of the secant, you go inside the parentheses that belong to the secant. So in the beginning, when you take the derivative of the secant, you assume that everything else is just x. So if I tell you what is the derivative of secant x, you say it's secant x tan x. So I'm going to write secant, but instead of x, I write the whole thing, tan x, which is 5 minus 3x. That's the derivative of the secant, meaning if what's inside was x and here x, you would be done. But what's inside is not x. So you step inside. So now we got done with the secant. So as if the secant didn't exist. And I'm telling you, take the derivative of 5 minus 3x. You say derivative of 5 is 0. It's a constant. And the derivative of negative 3x is negative 3. So just multiply that by negative 3 and you're done. Very simple, right? Okay, now let's move to a more advanced function. So let's say I will tell you, let's say g of x or g of t, okay, equals. We can have something with e, so e to the 3t, and another like trig function, so cosine. And we make that a function of t, so 2t. Let's make it cube. So the 2t is cube, not the cosine cube. Okay, be careful here. And then everything is raised to another power, let's say 5. And I want g prime of t. So I take the derivative of g with respect to t. What is the first thing you encounter from the outside? Meaning, I have some function plus another function, and the sum of them is raised to the power of 5. So really 5 is the exponent is the first thing you see, because you are coming from outside to the inside. Here from outside we encountered the secant, we went inside, we saw this function, and we multiply them together. Here there is a parenthesis with an exponent. So what do? We are taking the derivative of that exponent, something to the exponent. That thing, since you are not taking the derivative of what's inside, you assume it's x. So it's as if I'm taking the derivative of x to the fifth. X to the fifth is 5x to the 4. So you write 5. So I forgot to say here f prime of x, right? And here also I'm going to say g prime of t. So 5, and what's inside, as if it's an x. I write it as it is. I don't change anything. That's the derivative of the exponent. So I'm done with the exponent as if I didn't have this 5. So I have the sum of two equations. So I multiply by the sum of the derivatives, right? The derivative of e to the 3t is 3e to the 3t. And what's the derivative here? I have cosine of 2t cubed. Cosine is first, right? Because when you do it, first of all, you would multiply 2 by t, and then you cube that, and then you take the cosine. So it's the last thing you do. Like here, I take e to the 3t, and then I take 2t, cube it, take its cosine, add them up, and then raise to the fifth powers. That's why the 5 is the first thing you do, and you decrease this by 1. So I'm going to say plus, and I take the derivative of cosine, but the derivative of cosine is negative sign. So instead of, that's why I didn't try plus, I'm waiting. Derivative of cosine is negative sine, and everything else is the same, right? 2t cubed. And then what do? I'm done with the cosine. Notice, the rest is applied only to the cosine. So I'm not going to close the parentheses and multiply. No, this also only this part affects the cosine. It doesn't affect e to the 3t. So I'm done with the e to the 3t. I'm not going to see it again. And now I am here. So I took the derivative of cosine. It's negative sine of whatever. And then I take the derivative of 2t cubed. That's 3 times 2t squared. So I'm done with the cube. I go inside, I see 2t, so times 2 again. And then we clean it up. So I have 5 times e to the 3t plus cosine 2t cubed quantity to the fourth times 3e to the 3t. 2 times 3 is 6, so minus 6. And then I place this so that nobody thinks it's better to do this instead. So the 2t square is not inside. 2t square, 2t quantity square is 4t square. So in fact, instead of making that 6, I can make that 24t square. So 3 times 2 is 6, times 2 square is 24. And t square, here it is, sine 2t cubed. And that's a very complicated function. I don't think you will encounter it in real life, but if they give you a tough one like that in the test, again, take it one step at a time. Don't get panicked, don't get confused. Just take it one step at a time. Let's take a third one. So let's say h of x, for example, equals, since I know we have like a trig in each one, but I wanted a sine square or a sine cube because we didn't encounter some of those here. And let's say inside you can have 3x squared minus 5x plus 6, for example. I want to warn you, it's not a big deal, but when I say sine square, it means the sine of everything here. You find the sine of that function, and then you square the result. We don't write the square here because if I do it, some people will take 3x squared minus 5x plus 6, square that, and then they take the sine. But that's basically means sine of 3x squared minus 5x plus 6, and then quantity square. That's basically what it means. You take the sign and then you square it, not you square and then take the sign. So that's why, to reduce confusion, you know that you must have heard that from your teacher in trig. That's why we say that sine square. It means sine of whatever between parentheses, and then when you evaluate the sign, you square it. Okay. So basically, this is like I have x squared, right? Remember, we said the last thing we see here is the square, and you ignore everything else. You say whatever is inside is x. So I get 2 times sine 3x squared minus 5x plus 6. I just took the derivative of the square. After that, I see a sine function. That's what I see next. The derivative of sine is cosine. So I'm going to multiply that by cosine 3x squared minus 5x plus 6. I'm done with the sine, so I step inside. I see a function in x. Its derivative is, the derivative of 3x squared is 6x minus 5. And that's it. I'm done. Some people would say, oh, we learned in trig that 2 sine x cosine x is sine 2x. Yes, it is. So if you want, you don't have to. This answer is completely right. You will get full credit. But you can say sine and then multiply what's inside by 2. Double it. 6x squared minus 10x plus 12 times 6x minus 5. And that would show that you really understand that sine 2x is 2 sine x cosine x. And basically that's it. I think that's enough. That's a short one, but it illustrates the point. You start from the outside, taking the derivative of the function that is the outermost function, assuming everything else is just x. Don't change it. Don't touch it. I took the square, sine square, so I say 2 times sine, right? Because if it's x square, I say 2x. That's exactly what I did. And then you go inside, you see sine of something. The derivative of that is cosine of that thing as it is. And then you step inside and you multiply by the derivative, and that's it. Okay? I hope that was easy enough for you. And again, as usual, I commend you and I tell you, if you have any questions or any comments, please don't hesitate to write them in the comment sections, and I will get back to you as soon as I can. Thanks for watching. Hope to see you soon. Have a great day. Bye. Oh, sorry.